Let's graph this rational function. The first thing you need to do is factor anything you can to see if anything cancels out. The numerator has a common factor. If I pull out the x, then that's 2, and then x minus 2. Now the denominator can't factor, it's just x minus 1. And that's it. Nothing does cancel, so we can go ahead with the problem. When factors cancel, that's where holes come from. But so this graph won't have any holes in it because nothing cancels out. So right away, that tells me, for example, that B is not the answer and C is not the answer because I see the hole. This has like 2 holes in it. So we're down to either A or D already. Anyways, what shall we do first? Let's do the intercepts, the x and y intercepts. So for the x-intercept, on a function like this with no number on the end, you can just set the numerator equal to 0. So I am just setting 2 and x minus 2 equal to 0. Now this constant is not going to do anything. So x minus 2 equals 0 is the only thing that can give me a solution. So x is equal to 2. So that means my x-intercept will be 2, 0. Okay, so let's plot that. Alright, so there's my x-intercept. Now let's talk y-intercept. Alright, for the y-intercept, you know it's going to be 0, something. So we can just use our calculator to help us out. So let's use the table feature, clear out whatever's in there. And let's see, we have 2x minus 4 over x minus 1. I'm going to leave it in AskX mode. So I want to know what's happening at 0. So I've got 0, 4. So that's going to be my y-intercept. Alright, so there's my y-intercept. Now let's talk vertical and horizontal asymptotes. Alright, let's vertical asymptote. Vertical asymptote comes from setting the denominator equal to 0 and solving. So x equals 1 should be my vertical asymptote. So let's go ahead and get that graph going. I really wanted that to be in the front. So I think I'll send this to the back. Alright, so there's my vertical asymptote. Now let's deal with the horizontal asymptote. Well, the horizontal asymptote is all about the degree of the numerator compared with the denominator. Alright, the degree of the numerator is 1, the degree of the denominator is 1. When the degrees are equal, the horizontal asymptote is y equals leading coefficient over leading coefficient. So that's 2 over 1. So that's going to be y equals 2. So y equals 2 should be our horizontal asymptote. So let's put that on the graph. So that's pretty good. Okay, now let's plot some additional points to get a better picture of what we have. You can plot additional points by looking at the vertical asymptote. So remember, we had a vertical asymptote of x equals 1, as you can see. So if you were to put 1 on a number line, we're going to get 4 values to graph by doing this. We're going to go to the left and to the right of 1. So that's going to give me 0 and 2. But we are also going to go halfway between these numbers. So this is going to give me 0.5 and 1.5. So these pink numbers are the 4 values that I need. Now I've already got 2, check, and I've already got 0 because those happen to be my x and y intercept. So I really just need 0.5 and 1.5. Okay, so 0.5 and 1.5. I have 6 and negative 2. Okay, so these are the 4 points that I have to deal with. And that's enough to show us what the graph is going to look like. It's going to, of course, approach the asymptotes on the ends. While passing through the points we have. So this is what we're looking for. So we're looking for upper left and lower right. So A is looking good, D not so much. Whoa. Alright, so it's looking like our only surviving possible answer is A. But let's take a closer look. Let's at least check out the asymptotes. So we have an asymptote at horizontal at 2, vertical at 1, and then we see horizontal asymptote at 2 and a vertical at 1. Alright, we can even see the intercepts. The y-intercept is at 4, and there it is. The x-intercept is at 2, and there it is. So A is our answer.